6 steps for planning a cloud strategy. To design cloud strategies for speed and business value, organizations must first consider how cloud can solve business problems and enable new innovations. They should then focus on adaptable governance frameworks that have the flexibility to handle different implementation demands and risk profiles. Finally, they should organize for cloud success and to support the transformation of the organization as a whole. Cloud services can help organizations to be more agile and therefore more likely to succeed. They can also help to reduce costs and improve efficiency. However, it is important to design cloud strategies carefully in order to maximize business value. The following are 3 key CIO priorities that should be considered when designing cloud strategies. Strategy and innovation. Consider how cloud can solve business problems and enable new innovations. Governance and security. Focus on adaptable governance frameworks that have the flexibility to handle different implementation demands and risk profiles. Mobilization and migration. Organize for cloud success and to support the transformation of the organization as a whole. By considering these priorities, organizations can develop cloud strategies that will help them to achieve their business goals. Most businesses have completely implemented at least one major public cloud infrastructure as a service, IaaS, or platform as a service, PaaS, provider. Many are now considering adding a second cloud provider for additional application use cases. Multi-cloud strategies improve flexibility, but they also increase complexity and cost. To manage multi-cloud costs and complexity, one must define a strategy for cloud workload placement. The first step is to choose a primary, preferred provider. Once this is done, additional providers can be added in an orderly fashion, driven by specific business needs. A cloud workload placement framework should be developed that matches needs with the right fit cloud provider. This will help to ensure that costs are kept down and complexity is minimized. The importance of resilience is becoming increasingly evident in light of the rising frequency of cybersecurity threats, particularly ransomware, the ongoing organizational disruptions caused by the pandemic, and other natural disasters and catastrophes. Resilience is a key differentiator for businesses. If your competitors are experiencing delays and downtimes, while your business continues to operate, then your IT services have created an opportunity to demonstrate the superiority of your product. Reliability has historically been the responsibility of operators, who ensured it by building disaster recovery capabilities into the infrastructure. However, reliability is increasingly a feature of the application code itself. Gartner predicts that by the end of 2025, 30% of enterprises will establish new roles focused on its resilience and boost end-to-end reliability, tolerability and recoverability by at least 45%. Embrace modern IT resilience by shifting the focus to resilient application architectures, rather than individual service continuity. IT organizations build private and/or hybrid clouds for many reasons: regulatory requirements, data gravity, the momentum of legacy infrastructure, limitations of staff skill sets, or even project deadlines. However, complexity and unmanageability often doom private cloud projects. Organizations expect hybrid and private clouds to have the same ease of use, service consumption and integration opportunities as public cloud, but they rarely meet these expectations. Distributed cloud is an answer to this mismatch. The solutions extend the same native public cloud services to local infrastructure, while remaining under the same management schema. These cloud services are distributed to locations able to meet hybrid and private cloud needs while retaining the advantages of classic public cloud consumption. In the beginning, public cloud IaaS was delivered exclusively via virtual machines. But today, new virtualization methods are taking hold, including containers and serverless computing. As cloud computing principles become more embedded in application development and infrastructure operations, containers and serverless will become increasingly attractive deployment vehicles for code. Applications designed with cloud-native architecture require a higher degree of service discovery, programmability, automation, observability, robust network communications and security. Containers and serverless computing permit resource consumption to be better tailored to the actual requirements of applications. This improves infrastructure agility, automation, efficiency and cost optimization. Although public cloud infrastructure is hardly new, I&O technical professionals have not acquired cloud skills fast enough to satisfy the growing demand for cloud services. A lack of skills can delay or curtail a cloud project, inhibiting innovation. As it grows more difficult to hire skilled personnel, organizations will need to grow public cloud skills internally. Consider building a talent enablement program, TEP, designed to promote and develop the necessary skills and to cultivate the necessary roles within the IT organization. A TEP can help define skills the organization needs, improve recruiting efforts, and direct technical professionals to the most critical skills they need to improve on or attain. Thanks for watching. Like, comment, subscribe.